Okay. We are adding some new ways of how to take the derivative of something, but a question like this, the basics of it don't change no matter where we are in the curriculum. It says write the tangent and normal lines. Again, anytime it's asking us to write the equation of a line, we need two things, right? We need a point and we need the slope. And where those two things come from don't change either. The point always comes from the function. The slope always comes from the derivative. It's how we find those things that will change and evolve as we kind of learn more of this material and the formatting of the questions, etc. So they start out by giving us the x value of the point, pi over 2. The rest of the point always comes from the function itself, and our function is y equals cosine of 2x. So that's where I'm going to get my y value here by plugging in pi over 2 to our original function. So cosine of 2 times pi over 2 will give me my y value. Well, 2 times pi over 2, the 2's cancel, right? And we're taking cosine of pi. Cosine of pi is -1. Okay, so that's the first part of it, is just finding the point. Second part of it, finding the slope, and the slope always comes from the derivative. Well, on this one we have to find our derivative. That is a composite function. That is something we have to use our chain rule on. So to find our derivative of the outside, and the outside is cosine, is negative sine. Do not change the inside function, times the derivative of the inside, and the derivative of the inside would be 2. So we're looking at a derivative of -2 sine of 2x. And we want to know specifically when x equals pi over 2. So plugging 2 into that. So again, 2 times pi over 2, we're looking at sine of pi, and sine of pi is 0. And 0 times -2 is still just 0. So our slope is 0. And that's where this one was a good reminder for us. Okay, so we're looking at a slope of 0. Right? Well, what kind of a line has a slope of 0? A horizontal line. So then we have to think about how do we write the equation for a horizontal line, because our tangent is the one that uses that slope, right? We've got a slope of 0 or a horizontal line. Horizontal lines, what do their equations look like? Y equals. And it specifically has to go through this point. So it needs to be y equals the y value of that point, right? Y equals -1. That is the equation of our tangent line that goes through that point. So then our normal line is going to have the opposite reciprocal slope, or be perpendicular to that. Well, what's perpendicular to a slope of 0? Slope of undefined, right? So our normal line, its slope is going to be undefined, which makes it a vertical line. Vertical lines equations look like x equals, and it has to go through that point, so we'd be looking at the line x equals the x value of our point, pi over 2. So a good reminder on vertical and horizontal lines based on the slope. How do we write their equations? All of that. Any questions on that? Okay. Take a second and look at this chart. We've kind of seen some of these floating around. This might help clear up some of the questions on that circuit training worksheet that we started, which is due tomorrow with work, right? You're not getting through that without work. So whether your work's on another piece of paper or whatever, make sure that it is attached. You guys are turning that in tomorrow. So let's look at this one. Let y equal f of g of x. Use the following chart to find y prime of 2, or the derivative of y at 2. If they are setting it up like f of g of x, and we don't know what the functions are. These are just generic functions, f and g, and they give us some given values of the function and of their derivatives. When we look at this, I see a composite function, right? That's what that means. And if it's a composite function and I'm supposed to then take its derivative, well, composite function is why we use, or why we learned, the chain rule. So I have to apply my chain rule to f of g of x. And our chain rule says that the derivative is going to be done in layers. The derivative of the outside function, don't change the inside function. And I'm specifically going to do this at 2 because that's where they asked me to do my derivative, right? So g of 2 here times the derivative of the inside function. So derivative of the outside function, don't change the inside, derivative of the inside function, and we're doing all of this at 2. And then I start going to my table and finding values for these. Like g of 2, and be careful because they have both the original function and its derivative. G of 2 is going to be 3. So I can replace this part right here with 3. G prime of 2 is that last column, and G prime of 2 is 7. So then the last thing I need to go is go to that table and find f prime of 3. Here's f prime of 3 is going to be 5. So this part would be 5. And it looks like we would get an answer of 35. Questions on that? Now there's a couple different ways that you see this on your circuit training again. One that's like this, perfect, follow those rules. If they tell me what the functions are for f and g, like they give me the specific functions, sometimes, guys, it's going to be easier to just do the composition, clean it up, and then do the derivative than it is to think through it like this. So I would say if they hand you the functions, just do the composition. Plug one function into the other, clean it up, see what you get to. A lot of times that'll be easier. But if they don't tell us what the functions are, that's all we can do is just follow our rules and do it symbolically and then plug in the values from the table. Questions? All right, our last one. It says a particle moves along a line. And for question that we get to D here, I'm going to make that line the x-axis. So a particle moving along the x-axis, a line, so that its position at any time t is given by s equals t times cosine of 3 minus 4t. This is going to be a calculator question. We're going to get some ugly numbers on this, so grab your calculators. When you guys are doing trig on your calculators, make sure that you're always in radian mode. Sometimes we get switched out of that, so make sure, especially if your calculator gets reset, it actually defaults to radians. So just make sure you're in radian mode anytime we're using our calculators and typing in trig functions. So the first part is asking us to find the velocity of the particle. And remember, when it asks us at any time or at time t or whatever, they're just asking you to take your generic derivative of that function. So the first question, part A, is asking you just to take the derivative of the position function to get the velocity function. So go ahead and try that for a second. Go ahead, and here's your function up here, t times cosine of 3 minus 4t. As we start that one, what am I going to need to do? Which of our rules that we've learned over the last couple weeks do we need to kind of start that one with? Product rule, right? That's two functions being multiplied together, t and cosine of 3 minus 4t. There will be chain rule within there, but set it up starting with your product rule. So first times the derivative of the second plus second times the derivative of the first. Okay, so if I follow my product rule, our first function is t. Our second function is cosine of 3 minus 4t. Product rule says the first function times the derivative of the second function. Second function is a composite, so I'm going to have to do my layers. Outside layer, derivative of cosine is negative sine. Don't change the inside. Times the derivative of the inside function, which would be negative 4, plus second function times the derivative of the first. Well, the derivative of t would be 1. So if I clean that up on this first one, I'm going to go ahead and multiply t times negative 1 times negative 4, which would give us a positive 4t sine of 3 minus 4t. And the second function, when I multiply by 1, doesn't change anything, so it just stays cosine of 3 minus 4t. Questions on taking that derivative, finding our velocity. Okay, the second one asks us to find the velocity after 1 second, so we would be evaluating our velocity function for 1. Plugging in 1 for all of the t's. This is where we're going to have to go to our calculator, because right here I'm going to have 3 minus 4, which is -1, and the sign of -1 is not something that comes from our unit circle. We're going to have to grab that from our calculators. So go ahead and type this into your calculator. Let's make sure that we are getting the same answer. Okay, so the velocity after 1 second, we should be getting -2.826, which again, remember what that means about our function. That means our function is decreasing, our position is decreasing there, slope is negative. Part C, is the particle heading right, left, or stopped at 3 seconds? So now again, we're going to go to which function to decide on right, left, or stopped. Which function tells us about which way our particle is moving? So again, velocity function. When they ask us right, left, or stopped, we are again looking at our velocity function. So let's check out our velocity function at 3. All right. Is the particle moving right, left, or stopped? If we get an answer of -5.857, what's our answer? Left. Our particle is moving left at time equals 3. Now the important part here, why? That's your justification piece. So when they ask us why, the clearest, easiest way to justify anything about saying which direction our particle is moving is just identifying what kind of value we were getting for our velocity, and we got a negative value. So it's moving left because the velocity at time equals 3 is less than 0. Negative. Justified. Okay, that is the justification for why it is moving left. Questions on that? Okay, the last question I have on this topic is this one. Is the particle moving towards or away from the origin at time equals 3 seconds? So we just figured out its velocity. We know at 3 seconds it's moving left. So then does that mean it's moving towards or away from our origin? We've done a question like this. We needed one more piece of information. What are we missing here? Position. Where is it? Where is our particle that it's moving left at that time, right? So anytime the question is it moving towards or away from something, you have to know two things about it. Not only which direction is it going, we know it's going left, but where is it at that time that it's going left at that moment, okay? Because that answers the question. So it really is a twofold thing here. Where is it and which direction is it going? Anytime it's asking us if it's moving towards or away from anything, we have to know where and which direction. We know which direction. We just need to figure out our position then. So go back up to your original function. Let's find our position at time equals 3, and then we can answer our question here. So remember, the position function, our particle is not following that graph. That graph is telling us what value on our x-axis it is located at any moment in time. And at 3 seconds, our particle is located on our x-axis at negative 2.733. So at 3 seconds, it is located back here somewhere at negative 2.733 and moving left. So our answer is away, right? It is moving away from our origin at that time, and you have to know 2 things to be able to say that. You can either show those values, or to justify this, show that the position at time equals 3 is negative, and our velocity at time equals 3 is also negative, justifying the fact that it is left of the origin and continuing to move left, and that would be away from the origin. Questions on that? All right. You guys have a book assignment, and there's one problem that I'm going to have us kind of practice reading out of our textbook to help you through question number 70 on your assignment. I want you guys to look at example number 8 in that section, which is on page 157. The other part of today is just going to be spent on finishing up your circuit training and getting both of these ready to turn in tomorrow.